6, part 2. I want the tangent of the inverse tangent of 0.5. Remember what we did a while ago. If you put something in a function and then put it in its inverse, you get back to where you started from, as long as it's in the domain. So this one right here would just equal 0.5. Okay? But this one right here, remember inverse cosine is only defined from 0 to pi, or 0 to 180 degrees. That's 240 degrees. So here's how you can do this one. You can take a look at it and say, okay, I know where 240 degrees is. 240 degrees is in the third quadrant with a reference angle of 60. Remember, cosine is positive, negative, negative, positive. So what you really want to do is, remember, you'll get an angle out of this, because remember, the cosine of an angle gives you my ratio, and the inverse cosine of my ratio will give me my angle. So I have an inverse cosine of a ratio will give me an angle. So I'll get an angle out of this. So I want an angle out of this. So what, and 240 is not the right angle because it has to be between 0 and 180. So cosine of 240 puts me in the fourth quadrant with a 60-degree reference angle. Cosine's negative here. Cosine's also negative in this quadrant, so I can still draw it in that quadrant with a reference angle of 60. And my answer then would be 120 degrees. And if you want, pick up your calculator and double check it. I have the inverse cosine of the cosine of 240. 120. More, I have the cosine of the inverse tangent of 2/3. I can do this without using a calculator, but now notice that these aren't tangent and inverse tangent or cosine and inverse cosine, like these right here were same function except the inverse of the other. These are totally different functions. So here's how you can do these. Inverse tangent of 2/3, that's my ratio. Tangent of an angle gives me a ratio, inverse tangent of a ratio, so this is my ratio. Okay, so I have a ratio of 2/3. It's positive. Tangent's positive in the first quadrant. So I have the ratio of 2/3, opposite over adjacent. I know cosine, so this would be cosine of an angle, gives me the ratio of my x side to my r side. So all I have to do is find this missing side here, this r. And remember, a leg squared plus a leg squared equals a hypotenuse squared. So 9 plus 4, take the square root of that. 3 squared is 9, 2 squared is 4. So that's the square root of 13. So the x is 3. So I have 3 over the square root of 13, which is 3 square root of 13 over 13. The next example, cosine of the inverse sine of negative 4/5. Remember, cosine is only defined from negative pi over 2 to positive pi over 2. Since this ratio is negative, I have to be in my fourth quadrant, with the opposite side being 4, or negative 4, my hypotenuse being 5, and you can either do Pythagorean theorem, or maybe you remembered 3, 4, 5. There's my 3. Cosine of an angle gives me a ratio of x over r. My x side is 3. My r side is 5. So I don't even care what those angles are. All I need to do is find the sides of my triangle. Remember SOHCAHTOA? Don't forget, and this is just a refresher, and you should know this all by now. Okay? Just don't forget SOHCAHTOA. So for right triangles, ABC is shown. I want to find what we're missing. Okay? So let's find what we're missing. The easiest thing to find first is angle B. because the sum of the three angles is equal to 180, the sum of these two equal 90. So angle B, I could just do 90 minus 25 and get 65. Okay. Next, I could find B or C. It really does not matter which one. Okay, so I'm going to find B. And it doesn't matter if I use the angle 25 or the angle 65. It's still going to be a tangent. I could do the tangent of 65 is B over A, or B over 40, or I could do the tangent of 25 is 40 over B. It doesn't really matter. So in your calculator, you can either put 40 tangent of 65, or you could put 40 divided by tangent of 65, and either way, you'll get about 85.8. And then C, there are multiple ways you could do it. You could do A squared plus B squared equals C squared and find it. You could also use a trig function. I could use the sine of 25 is equal to opposite over hypotenuse, so C is equal to 40 over sine of 25. It does not matter which way you do it, but you'll get about 94.6. I could have used the cosine of 65 is 40 over C. Okay? Or you could use A squared plus B squared equals C squared. Now I have one where I know two angles, or two sides, and I want to find my missing angles, and I want to find my missing side. So first of all, I'm going to find angle A. And you can find C first if you wanted. I'm going to find A first. Remember A. I have an opposite side that I know. I have an adjacent side that I know. Opposite and adjacent is tangent, so I could write the tangent of A is equal to 50 over 30. Okay? And then in your calculator, then A is equal to the inverse tangent of 50 over 30, or 5/3. So you could pick up your calculator. Right there's my calculator, and I could do the inverse tangent, second inverse tangent of 50 over 30, or 5 over 3, same thing. And you get about 59 degrees. And that's about what I got somewhere. 59 degrees. So if that's angle A is 59 degrees, the sum of these two equals 90 degrees. So that's about 31 degrees. And then to find C, you could do A squared plus B squared equals C squared. Not the only way to do it. And you'll get about 58.3. You could also do trig if you wanted, though I would store this in your calculator so you don't make a mistake, a rounding error. So after you do that, store it in your calculator and you can use that angle again. And that's part 2.